So in our last class, we have studied what is STL, that is a standard template library. We have covered the definition of the main three components of STL. The main three components are container, objects, and algorithm. So we have discussed about what is a container, what is algorithm, and what is object. Today we will see in details how this algorithm work. In our last class, we have seen one of the containers, that is vector. We have seen a program in which we have seen how a vector work, how we can declare a vector, what are the header files that we have to add. So in case we missed the last class, here is the brief idea. So STL, standard template library, is a way that you can manipulate the data. What is data manipulation? Data manipulation means you can add data, you can modify data, you can delete data, you can update data, and so on. In the STL, there are three main components. Components are a container, where we store the objects. So this is the container. And objects means object can be a integer, object can be a character, object can be a float, object can be a class object as well. So container is where you will store the data. Okay, then we have the we have the algorithms. Using the algorithm, you search the data, you manipulate the data, you do different operations. Okay, one example of algorithm, that if I give you an array and if I ask you that find the maximum element of the array, that is an algorithm. So you will write the program that will find the maximum element. Then in an array, you can do modify operations as well. Okay, you can shift elements, so on. Then we have the iterators. Iterators are helps us to browse or to actually go through the data. So combining these three, we learn STL. Now, so again, the definition: a container is a way to store the data, whether the data consists of built-in types such as integer, float, or class objects. So that is container. A container can fall into two main categories. It can be a sequence, it can be associative. Sequence means one after another, just like array. Okay, so and other examples are vector, list, and dequeue. And associative containers are basically a set or multi-set, map, or multi-map. So we'll talk about them as well. Now there are some specialized containers, okay, that actually we derive from the sequence containers, that called stack, queue, and priority queue. So here there are two questions: what is a container, what are the types of container, and their examples. Now we will skip the details of sequence container. We'll just see the name. So we have seen that in our last class, ordinary C++ array is a sequence container, vector is a sequence container, list dequeue is a sequence container, and associative containers are set, multi-set, map, and multi-map. Now, each of these containers have some member functions. We use these member functions to actually perform different tasks on the data. So container also need member functions to perform simpler tasks that are specific to a particular type of container. So we have these functions like size, empty, max size, begin, end, begin. So using, like for example, using size, we can find how many elements are in our container. So if you're using an array, and if you just call a dot size, it will return that whether there are 5 elements or 6 elements in the array. Another example was this: let's assume that you have declared an array, the array was size 10, A10, but you have only stored one element. Okay, so if I ask you what is the size of the array, okay, it will return, it will say 10, but the number of items that you have in your array is 1. So you have to understand the difference. There's a little bit of difference. And if I ask you what is the max size, then it will show you 10. So if I declare an array, so if I declare an array of size 10, okay, and for now all the elements are empty, okay, I didn't store any informations, then I inserted one information, array 1 equals to 5, okay, so all the rest part is empty. So if I call a dot size, okay, it will return 1. So a dot size will return 1 because we have only one element in the array. But if I ask a dot max size, it will return 10 because we can store 10 elements in the array. So depending on other cases, this may differ, but this is the basic idea. Now Same way, begin will show us when from where the elements start, end will show where the elements stops. Then we have this container adapter. So from here you have to let me highlight which part you need to understand. So this, first of all, this is a special purpose, sorry. So first of all, this is a okay, where is it? Yes, so first of all, it's a special purpose container. That means, again, it stores the data, but there is special purpose. So how this is special? Okay, so what we do, these containers, okay, we actually construct them using the basic containers, but we use them for special interfaces. Now let's see some examples. So the special containers implemented with container adapters in the STL are stack, queues, and priority queue. So here you can see three examples: stack, queue, and priority queue. How this works, you will learn in your next course, that is data structures. In that course, you will have a whole chapter on stack, whole chapter on queue, and priority queues. But just know that these are special purpose containers, and these are implemented with container adapters. Now the question comes that what is a container adapter? Okay, so here is the answer. The normal containers mentioned previously, okay, using construct called container adapters. So container adapter is a construct by using which we can create a special purpose container, sorry, special purpose containers. Again, what is container adapter? It's a construct by using which we can create or we can implement special purpose containers. Now, so here are some examples of special purpose container. Now remember here, stack, queue, and priority queue can be created from different sequence containers. Okay, so even though it might seems like stack and queue is a simple idea, but you can create a stack and queue from array, from linked list, and from so on. Now here are some of the again, so what is the implementation? It can, stack can be implemented as a vector, it can be implemented as a list, or it can be implemented as a queue. So vector, list, queue, all of them are containers, but you can create the stack using one of this. Then we have queue, it can be implemented by list or dequeue. So you don't have to memorize this, you just have to know which there, what is a container adapter. Again, the answer is this is a construct by using which we can create special purpose containers. And what are the special purpose containers? It can be stack, queue, and priority queue. That's it. Now next question is algorithm. So we will learn a bit about algorithms. So normally there are some typical STL algorithms that are very simple operations that we have to do in day-to-day data. So it can be find, you want to find the information. For example, whenever you go to Google, okay, this is what you do. You want to find that how many are information. So this is a find operation. Then count, count the number of elements that have a specific value. Then equal, so you want to find that whether compares contents of two container and return the true if the elements are equal. So like if you want to see that whether two elements are equal or not. Then we have the search, copy, swap, okay, sort, and other algorithms as well. So we'll not go into the details, but I will show you programs that how this work. So let's take an array, for example this one. So this is an array of 8 elements, 42, 31, 70, 80. So you see the elements, they have no specific order. So if you just use this sort function, okay, and you start from array to array 8, that means first index to last index, what it will give you, it will give an array that is sorted. That means all the elements will be sequentially. I will show you in the in one of the programs. Now the next one is iterator. So again, what are the iterators? Iterators are pointer like entities. So basically they're like pointers that are used to access the individual data items, which are called elements in a container. So three part. First of all, iterators are point like entities. Number two, we use iterators to access the individual data items in a container. Okay, and we are also used to move sequentially from one element to the next element, and this process is called iterating through the container. So you will face this term more and more in your upcoming courses as well, that whenever you move through one element to the next element, we call this a iteration. So there are different names: iterators, iteration, okay, iterating. So these are the same terms. So you can increment iterators with the plus plus operator. So normally in our last class we have seen an example that in a loop, for loop, in a normal for loop, we start with I equals to 0, then we write I less than array size, then I plus plus. So that is the simple example of iterator, where using I we are actually going from one element to the next element. The difference is we use this pointer operator to obtain the value of the element. So normally uh, in uh, in case of loop, we use normal looping index I, array I plus 1. But in case of iterator, we have to use a pointer. So in our last class, we have seen an example. In case you missed it, you can go back and see the examples as well. So let me share the code blocks just to. So this is the example that we have discussed in the last class. You see, this is the iterator. First, we have declared the iterators. The name is itr. Itr starts from v1.begin. So this is a function that we have seen in our STL. Let me go back and show. Yes, so you see, this is the one that we have seen in case of our STL. So you see, this is a function begin. It points to the, it returns the iterator at the start of the container. So here, so this is our iterator. If I write v1.begin, it will point us to the beginning. Then we, using v1.int, we continue until last. So this one is basically writing that until you reach last point, don't go. Then I plus plus, it increasing the value by 1. And then whenever we're printing it, we are printing with a star. Okay, so what if I don't print a star? What will happen? Let's try to run the program. So these are the elements we have here. So you see, this will not work. So you have to use a pointer star so that it prints the value. Okay, so let's go back to the program. So we have this iterators. Different classes of iterators must be used with different types of containers. So if you're using like vector, you use one type of iterators. If you're using list, you are using one type of iterator. But there are three major classes, okay, of iterators. The iterator can be forward, it can be bidirectional, it can be random. Iterator, three major classes: forward iterator, bidirectional iterator, and random access. A forward iterator can only move forward through the container one item at a time. So by random access means it can go randomly at any element, and bidirectional means that it can go to forward or backward. So in this way, we have these three major class of iterators. Now, here are different types of iterators. We have talked about that. Random access, it can read or write. Okay, bidirectional, it can read, it can go forward and backward. Forward iterator, output iterator, or input iterator, it can only go forward only. Okay. So normally in a program, most cases we use the bidirectional iterator. It makes easier for us to iterate the data. Now we have, even though STL seems like a very good idea, but there are some problems with STL as well. There are some, so what is the first problem? Is that first one is sometimes it's hard to find errors because compiler reports them in a header file. So you will face this in case of file as well. So if there is some problem in the program, okay, even though the problem is in the program, the iterator, sorry, the compiler will show you that the program is in the vector or in the list or in the array list. Okay, so first problem we can say is sometimes hard to find error. Okay, because compiler cannot pinpoint what's the problem is. Okay, so in that case, what we do, the solution is you need to use commenting to see which line is not working. This is called brute force approach. Then second is that we use pre-compilation of header files, okay, which speed up the compilation dramatically. Okay, but it may cause problems with the STL. So problem is whenever we use the pre-compilation of header files, okay, it speeds up the compilation. That means it works fast, but the problem is that it may cause problems with the STL. So this is another problem. Then we have sometimes STL generate spurious compiler warnings. Okay, so these warnings actually, even though they are harmless, okay, so we can actually ignore those, but these are one of the drawbacks. And apart from these minor complaints, Okay, the STL is a surprisingly robust and versatile system. So you have to remember that STL is very, very good if you can use it. And this is one of the best features of C++. If you ask me, sir, what should I learn from C++? I will tell you that you need to learn two things. You need to learn what is the object-oriented features. Forget everything else, just like what is inheritance, what is polymorphism, what are the class, and how we can use class to apply inheritance, function overloading, overriding. So these are the features that we learned in our first term in the midterm. And then I will tell you that learn STL, because if you know STL, your life becomes very, very easier. I will show you why. Just wait a bit. In the next class, I will show you why your life becomes so much easier. So let's start with this. So remember, we talked about there are three components of STL: containers, where we store the data; iterators, which we use to browse the data or go through the data; and then the third part, the algorithms. So let me show you how the algorithm work. So there are different algorithms. We have seen the list here, that it can be search, copy, swap, sort, merge, accumulate, different, right? So let me show you how it works. So this is the first one. I will copy this one to compiler and run the program. Let me just run it. Okay, so I'm let me format the code. So whenever you're copying the code, just check for this different brackets. Sometimes the bracket in the compiler and the book doesn't match. Yes. So the first one, let me explain what happens here. So first of all, we have included algorithm. So whenever you are trying to use the features of algorithm, you have to include it. Okay. Then we have declared an array. So the array is sorted array. You see 11, 22, 33, 44. So what is the purpose of this program? Its purpose is to find an element. Okay. And what it does, it finds the first 33. Okay. So from a given array, if I want to find where is the first 33 or the first 44, okay, we use this find algorithm. Okay, so what is the syntax? First you have to declare the header file for algorithm, then you have to declare a pointer. Why we are declaring a pointer? Because we have to use it for as a iterator. Then we use pointer, that is we declared here, okay, equals to find. This is the name of our function. And then we pass the array index, array 0 to array 8, and then we pass the element. So what the program returns, okay, it will return that first object with value 33 found at offset, then it will return the location. I will come to this part. Let me run the program again. You see the output, the first object with the value 33 found at offset 2. So the offset starts with 0 location. Okay, so this is the first location, 0, 1, 2. So that means in the offset 2 we have found 33. Let's change the value. Let's try to find out let's say uh, 88. Okay, so if I run the program, the first object with the value 33 found at offset 7. So that means 0, 1, 2, 3, 4, 5, 6, 7 here. If you want to use a normal indexing, let's assume I don't want to use I want to change the variation. So can we do it? Let's try to run the program and you will see that it will give you an address. That means I found it in this location. Okay, so if we want to print the location, we can do that as well. Now you might ask, sir, why the location is in this bizarre way? Because we are using hexadecimal. Okay, now what if I want to find a number that is not there? So if let's assume 7, 5. Okay, is there an element called 5? The answer is no. So let's see what happens. If I run the program, see, it will return offset 8 because there is no offset 8 here. That means it will give you a random location. Let's give 500. Okay, 505. Run the program. You see, whenever there's no element, it will either return error or it will return a random offset. So we know clearly that in our array, there is no 8 offset. That means the element is not there. Okay, so let's go back here and let's come back with what if we just write 5. Okay, what will happen in that case? So run the program. Okay, you see this is returns offset 5. What does this mean? This means that the range of values you are trying to ask, that in between this is not there. So I don't want to complicate this too much. For now, just try to remember this, that whenever you are trying to use the find operation, okay, normally if you don't use uh, don't use a find function, you have to write an algorithm that will search all the elements one by one. But if we use this find function, all you have to do, you have to define the range of the array. So this is the starting point of the array. This is the last index of the array, array plus 8. And this is the element that you're trying to find. And then it will return you exactly which position the array is in. Now, let's go back to our program. So as you can see, okay, just let's pause 2 minutes. So this is the another algorithm, that is the count algorithm. So again, what we do, okay, I will not run the program. You can see it from here. Okay, so first again, what we do, we declare the algorithm in the header file. Okay, after including in the header file, okay, we declare the array, and then we declare the type of the array, and then we just call the count function. So this program, what it will return, the output will be there are 333 in the array. So this count, what it does, from a given array, it provides you how many times there's an element. Now think about this. We know that this algorithm, they work for all type of STL containers. So if you want to apply this onto a class, you can do it. If you want to apply this in case of a string, you can do it. If you want to apply in case of a float, you can also do it. So if we don't use STL, you have to write separate program to search integers. If you have to write a separate program to search characters, if you have to string as well. So for different data types, normally we have to write different type of algorithm or programs. But if you use algorithm, this count function, it will help you to automatically identify how many occasions are there. Then if you go for the sorting algorithm, this is also here you have to just provide the range of the array, and then it will automatically print you the sorted array. So in all of the cases, there is a similarity, whether this is the sorting algorithm or the count algorithm, okay, or the find algorithm that we saw first. If you look closely, okay, what we do in all of this algorithm, we give the name of the array and the index in which we want to find. So basically we provide the range of the array and the element we want to find, okay. And the count, we have again provided the name, we have called the count function, okay. We have given the name of the array, this is ARR. We have provided the last index ARR plus 8, and we have provided the element that I want to count. In case of sort, we have called the sort function, we have called the array. That's it. We didn't need to provide any other elements. So we just need to provide the range. That's it. Rest of the tasks are being handled by this algorithm. So you see how much easier it makes our life for us. Whenever you're developing a project, you don't have to worry about all this sorting, searching, or find operation. You can just call the STL and you can do it. If you have developed a project in C, you know how difficult it is to manage the data, but in case of STL, it makes your life much easier. You can just call these functions and they will do the task for you. Now then we have again the search algorithms, okay. And again in this, let's assume this is our this is a more complicated program. So let me run it in the compiler and show you how it works. Let me go back to the compiler. Yeah, this was for search. Okay, so search dot cpp. Now let's run the program here. So let me explain what happens here. So normally whenever we think of search, we can search one element that we can search whether the 33 is there or not, okay. But in this one, they have implemented a here. In this one, we have used the find, and here this is the search. So initially both are same, right? Finding something, searching something, but there's a difference. If you look at this program, in this one we are finding a specific element, 88 or 22 or 33, whether the element is here or not. But in case of In case of search, what we're doing, we're trying to search a pattern. That you see, this is on my given array, and in this given array, whether I have these elements or not, 11, 22, 33. So you see the difference. We are not looking for an element, but we are looking for a set of elements, that is 11, 22, 33. So if I run the program, okay, so you'll see it will already I have already run the program. So it will see that match at 3. That means 0, 1, 2, 3. So from the third location, we have a match of the pattern. So we have found the pattern. So if I just change this a little bit, let's make it 12 and let's try to run the program again. Let's see what happens. So no match found. That means the pattern you are looking for, it can be a name. Okay, there is no match. So what we start with, okay, just run the program in your own computer and check for different outputs. We again start with the pointer iterator, then we call the search function. We start with the source. That means this is our first array, source array, and the last index of the source array, that is source plus 9. And this is our pattern array, pattern plus 3. Okay, then if we just find it, if pointer equals to source plus 9, then we print that no match found, because there is no data that matches the index, but else we just point the index. The rest of it is same as this function. Okay,